Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now video for Course 1 Honors for Thursday, May 7th, 2020. In this Do Now, we're going to start talking about a new kind of function, and this is called an exponential function. So what we need to be doing in this function is we need to be thinking about what we did yesterday with the quadratics graphing. Okay, so what we need to do is we need to plug in numbers for x. We need to see what comes out. We need to build a table, and we need to use that table to make a graph. So here you can see the points, the x values, 1, 2, 3, 4, 0, -1, -2, and -3. What I want you to do is plug in each of those numbers for x using any laws of exponents as needed, fill in the table, plot whatever points you can, and you'll have your graph. So take a moment, pause the video, fill out the table, and do the best you can to make the graph. And then when you're ready, unpause, and you can see what I got. All right, so first of all, we know that anything to the power of 1 is the same thing. So 2 to the power of 1, that should give us 2, okay, because it's to the power of 1. So we get, that number back, 2. Okay, we plug in 2. Well, this is 2 squared, 2 times 2, and that's 4. This is 2 cubed, so 2 times 2 times 2, that's 8. See the pattern here? 2 times 2 times 2 times 2, 16. Now remember, anything to the power of 0 by the laws of exponents is always 1. Okay, -1. If I look at -1, sorry, sometimes my thing kind of dances around there. So -1, remember, it's 1 over 2 because you flip it and you do it to the power of 1. So it's 1 over 2 to the 1. This is a quarter because it's 1 over 2 squared. And this is an eighth because it's 1 over 2 cubed. And let's graph that. 0, 1, 1, 2, 2, 4, 3, 8. 4, 16 is not on the graph, so we leave it out. -1, 1/2. -2, a quarter. -3, a 16th. So if we take a look, we know it's going to continue to shoot up in this direction based on what happens with 4. We have this info here. And then if you think about it, what's happening is it's approaching this line, but it's going right up next to it, but it's not touching that line. It's never going to actually be equal to 0. Okay, so this is what we call a graph of an exponential function. A couple things you can notice. First of all, it's got a domain of -infinity to infinity. Everything can be plugged into it. Its range is not everything. Notice the range is only numbers that are greater than 0. Remember how I said it's never equal to 0, but it can be greater than 0. You see, if you look at the y values, okay? This function's always increasing. It never decreases. Its y-intercept is 0, 1. So a lot of interesting features there. And we'll spend some time doing analysis on these as well. All right, so hopefully you're able to get that right. If so, congratulations, very good. At this point, I'm going to show you a bonus graph. You can be done here, and if so, have fun with the lesson materials for today. Otherwise, stick around because I'm going to do another example. This is the function f of x equals 1/2 to the x. So a half to the power of 1 is a half. A half squared is 1/2 times 1/2. A quarter. A half cubed is a half times a half times a half. 1/8. A half to the fourth is a half times a half times a half times a half. A half to the 0 is 1 because anything to the 0 is 1. a half to the negative 1. So first we would flip it, and it would become 2 over 1. And then the exponent would flip to a positive 1, right? And that would be 2 to the power of 1, which is 2. Similarly here, this would be 2 to the power of 2, and this would be 2 to the power of 3. So remember, one of the most challenging things to remember is the negative exponent flips the thing that you're doing the exponent or the power to. So in this case, the 1/2, it flips the 1/2 to a 2 over 1, and then the exponent goes from a negative to a positive. Okay, so that's something that's going to take a little bit of practice potentially. So we've got 0, 1, negative 1, 2, negative 2, 4, negative 3, 8, 1, 1/2, 2, 1/4. So this is kind of like that other graph, but mirrored. Okay, instead of always being increasing, this is always decreasing. It does have the same domain and range. You can plug anything you want in, and the x values, the y values that is, are always greater than 0. Because you're always multiplying by a half, right? When you multiply by a half, you can multiply by as many times as you want, but because you're always multiplying by 1 on the top, you can multiply forever, and it will always be a number that is greater than 0. Because unless you multiply by 0 on the top, you're never going to get 0. Right? You have to get 0 in the numerator to have a fraction equal to 0, right? So same domain, same range, except this one is always decreasing instead of always increasing, right? As we go from left to right, the y values are always going down. They're going down by a lot at first, but then as x increases, as x goes to infinity, right, the decreasing is going a lot slower, right? First it goes down by 4, then down by 2, then down by 1. So you can see it's going down by less and less. Then it only goes down by a half. Then it only goes down by a quarter, right? Then it only goes, right? So it's going down by less and less and less as we go on. All right, so keep it up, folks. Hopefully this was helpful to you. I'm excited to really jump into some great new stuff with you. Best of luck. Don't forget to love math. And remember, you can do it. All right, thanks for watching and have a wonderful day.